Hello students, in today's class we are going to revise the next chapter, limits and derivatives, which is again a very important chapter where we will see our continuation in class 12. So what is meant by limit? First let us see about the limits. As x tends to a, f of x will tend to L. Then L is called the limit of the function f of x, which is symbolically written as limit x tends to a, f of x equal to L. Limit is not the actual value, limit is the value where it approaches. If x approaches some value a, then its functional value will approach another value which is L. That is called the limit of the function. Then we have seen, we will denote it as limit x tends to a, f of x equal to L. When x approaches the value a, f of x will approach the value L. That is what the meaning of the limit. Then we have seen two types of limit, left hand limit and the right hand limit. Limit x tends to a minus, left hand limit is denoted by a minus, this is the expected value of f at x equal to a. Okay, it gives the value of f near x to the left of a, from the left hand side where it approaches. That is called left hand limit. Right hand limit is from the right hand side where it approaches is called right hand limit, and we will denote it by a plus. Only when both left hand limit, right hand limit exist, and if both are equal only, the limit of the function will exist. Okay, and it is called as limit x tends to a, f of x equal to L. That is what given in the note. If the right and left hand limits coincide, we call that common value as the limit of the function at x equal to a, and we denote it by limit x tends to a, f of x. Hope you remember all these things, right? So left hand limit, right hand limit both should exist and both should coincide. Then only the limit of the function will exist and it will be equal to that value, right? Then we have seen some important results like algebra of limits. Limit x tend to a, f of x plus g of x is nothing but limit x tend to a, f of x plus limit x tend to a, g of x, which means taking limit of sum of two functions is same as finding the limit of the functions and then adding, which is true for subtraction, multiplication, division, and even for a scalar, right? Then we have seen this result. What is this? Limits of a polynomial. Limit x tend to a, f of x is equal to f of a. When x tends to a, limit x tends to a, f of x will be equal to f of a if limit x tends to a, x is equal to a. Limit x tends to a, x is equal to a, limit x tends to a, f of x equal to f of a. It is like substituting the value of that a in the polynomial when x tends to a. You got it? When x tends to a, you have to substitute the value as a in the place of x in the function f of x. Then we will get the limit. Okay, that's what this result says. Then we have seen another theorem, limit x tends to a, x power n minus a power n divided by x minus a equal to n into a power n minus 1. This we will use in problems. Limit x tends to a, x power n minus a power n is equal to, x power n minus a power n divided by x minus a equal to n into a power n minus 1. Right? Based on all these results only we have solved problems. So what are all the things we have seen? Limit x tends to a, x is equal to a, limit x tends to a, f of x equal to f of a, limit x tends to a, x power n minus a power n divided by x minus a is n into a power n minus 1, and the limit x tends to a, x is equal to a can be extended for any power n. Okay, now let us see one example. Limit x tends to 1, x cube minus x square plus 1. This is what they asked you to evaluate. So how to evaluate? Using the algebra of the limits we can separate. Limit x tends to 1 x cube minus limit x tend to 1 x square, limit x tend to 1 1. Right, now using this result, x tends to a, x power n is a power n. So 1 power cube and 1 square, and this is 1. This is independent of x. So this is going to be 1. You can simplify and find the limit. And one thing which we have noted here is you should not get 0 by 0 form. If you get 0 by 0, we have to reduce the given question. We have to reduce it and we have to eliminate the term which leads to 0 by 0 form, and then we have to apply the limit by using any of the substitution method or using any of the results. That's what we have seen. Hope you recall. Okay, so if you see this question, if we do the same procedure as we have done for the previous problem, limit x tends to 2x cube is nothing but 2 cube minus 4 into 2 square plus 4 into 2 divided by 2 square minus 4, we got 0 by 0. So what we are going to do is we are going to reduce this by factorizing. So from the numerator we have taken x as common and denominator is x square minus 4, right? We should not get 0 in the denominator, right? So x square minus 4, it can be written as x plus 2 into x minus 2. And the numerator we have taken x common and this can be written as x minus 2 the whole square. So 1 x minus 2 and x minus 2 will get cancelled. So we got x into x minus 2 divided by x plus 2. Now if we apply the limit, we are getting 0 by 4 which is equal to 0. We should not get denominator as 0. 0 by 0 form we should not get. But we can get 0 in the numerator and any number in the denominator. It doesn't matter because the answer is going to be 0. So how to reduce this 0 by, how to avoid this 0 by 0 form? You have to check it. If you are getting 0 by 0 form, you have to reduce the question and try to eliminate the term which leads to 0 by 0 form and then proceed with the usual steps. Okay. This is another method of problem. Limit x tends to n, x power 15 minus 1 divided by x power 10 minus 1. Directly if we apply the limit, we will get 1 minus 1 divided by 1 minus 1. So 0 by 0 form. So as I told you, we have to reduce the question either by factorizing it or using any of the results or using substitution method. So previous problem we have seen how to reduce it, how to factorize and reduce and eliminate the term which leads to 0 in the denominator. Now in this problem we are going to use this result, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. So numerator we have x power n minus a power n because limit x tends to a, here x tends to 1, we have 1 only. 1 power 15 is going to be 1 only, so they have given 1. So in order to apply this result, we should have x minus a in the denominator. So we are going to both divide the numerator and the denominator by x minus 1, right? So now we got this result. We can apply this now. So limit x tends to 1, this divided by limit x tends to this. Now limit x tends to a power n, x power n minus a power n divided by x minus a is nothing but n into a power n minus 1. So 15 into 1 power 15 minus 1. Similarly, this is 10 into 1 power 10 minus 1. So we got the answer. So this how also you can do. This is another type of problem, right? And now let us see another method of problem. Here limit x tends to 0, square root of 1 plus x minus 1 divided by x. Again, if we put apply the limit directly in the question, we will get 0 by 0. Okay. So how to avoid it? Here we cannot factorize. Here we cannot use the result which we have used in the previous problem. So what are we going to do here is we are going to adopt substitution method. So we are going to substitute this 1 plus x as some other variable y. I told you during the class itself, during my teaching period itself, whenever you are substituting, kindly be aware to change the limit of the earlier variable to the new variable. Most of the students in hurry, what they will do the correct substitution, but they will forget to change the limit. Okay, that will lead to wrong answer. You should not do that. As soon as you substitute the variable, immediately you should change the corresponding limit as well. So here we have substituted 1 plus x as y. So x is going to be y minus 1. Okay. So when x tends to 0, what will happen to y? As x tends to 0, y will tend to 1. Because if you put 0 here, this minus 1 will go to other side. So y will tend to 1. Right? Or else here also you can substitute. So limit y tends to 1. In the place of 1 plus x, it is y minus 1 divided by y minus 1. Now root y is nothing but y power half. Now this is of the form limit x tends to a, x power n minus a power n divided by x minus a, as we have done in the previous problem. Here a is 1 and n is going to be half. So n into a power n minus 1. So half into a is 1 whole power n minus 1, half minus 1. So we got an answer. So as of now we have seen 3 methods to avoid 0 by 0 form. If you don't get a 0 by 0 form while applying the limit, you can arrive at the answer directly. If you end up with 0 by 0 form, you have to do certain manipulations there in order to avoid it. What are all the manipulations you can do? Either you can reduce it and eliminate the term which leads to 0 by 0 form by using factorization, or else you can use this result, or you can substitute. Okay. Then we have seen limit of trigonometric functions. Two important results. Limit x tends to 0, sin x by x is 1. Sin x by x we should have, and this x should tend to 0. Limit x tends to 0, sin x by x is 1. Similarly, limit x tends to 0, 1 minus cos x divided by x is 0. Okay, limit x tends to 0, sin x by x is 1. Limit x tends to 0, 1 minus cos x by x is equal to 0. Using these trigonometric functions and relations, we have solved many problems again. Few I will show you. See this example now. Limit x tends to 0, sin ax by bx. So again, when we reach 0 by 0 form, you can reduce it further using any of the results. We know the relation using the result, the result using the trigonometric function sin x is limit x tends to 0, sin x by x is equal to 1. Okay, so here we have limit x tends to 0, sin ax. So denominator also we need ax, and that ax only should tend to 0. Then only we can apply this result. So we are going to multiply and divide by ax. As x tends to 0, ax also will tend to 0. You have to mention this if you are going to use this result. Okay, and this x and x will get cancelled. So this has become a by b as a constant. Now we got limit ax tends to 0, sin ax by x, which is nothing but 1. So the answer is a by b. Okay, hope you got it. And we have seen many problems like this. See this example, limit x tends to 0, cos 2x minus 1 divided by cos x minus 1. So what we can do here, we can apply cos 2a formula. What is cos 2a formula? 1 plus 2 sine square a, right, minus 1 divided by cos x is 1 minus 2 sine square x. Hope you remember what is cos 2a. Cos 2a is 2 cos square a minus 1, or 1 minus 2 sine square a. Right, we have two formula. Here we have used in terms of sine because we know the result using sine. So cos 2a can be written as 1 minus 2 sine square x, and this minus 1, and we have denominator single angle, right? So 1 minus 2 sine square x by 2 minus 1. So we got sine square x divided by sine square x by 2. Now what are we going? We are going to multiply both numerator, and we are going to divide and multiply by x square in order to use the result limit x tends to 0, sin x by x. So this has become similarly here x by 2 the whole square. Then only we can write it as whole square. Okay, sin x by x the whole square into x square. Here sin x by 2 divided by x by 2 the whole square into x by 2 the whole square. So for this we can apply the result. For this also we can apply the result. Here x square will get cancelled. So we got 1 by 4 in the denominator. So when it goes to the numerator we will get 4. Now if we apply the result for the numerator, we will get 1, because as limit x tends to 0, sin x by x is 1. And here we have x by 2, so limit x by 2 should tend to 0. As x tends to 0, x by 2 will also tend to 0. Therefore, denominator also we got 1. So the answer is 4. So there is no hard and fast rule like this, only you have to proceed. First step is this, second step is this. No, we cannot describe the steps. Okay, as far as problems under limits are concerned. So what you should do, you have to analyze the question and you should think in a proper way. Whichever result you are going to apply, accordingly you have to proceed and do the manipulations there. Yes, hope you recalled all these things what we have learned under this chapter. See this question, this is another type where we have substituted in trigonometric function. Limit x tends to pi by 2 tan 2x divided by x minus pi by 2. If we put pi by 2, we are getting 0 in the denominator. So we have to eliminate 0 by 0 form. So what are we going to do? We are going to substitute the denominator, which leads to 0. So x minus pi by 2 we are going to substitute as y. Okay, so x will become y plus pi by 2. So x tends to pi by 2, y will tend to 0. If we put pi by 2 for x, pi by 2 minus pi by 2 will become 0. So y will tend to 0. So replace here, limit y tends to 0, tan 2 into, instead of x we have replaced y plus pi by 2 divided by y. So if we multiply, we got tan 2y plus pi divided by y. Right? What is tan 180 plus theta? It is going to be tan theta. So tan 2y divided by y. Again tan can be written as sine by cos. So sine 2y divided by cos 2y. Now in order to apply sine result, we need 2y. Right? So we have multiplied and divided as we have done in the previous problems. So as limit y, as y tends to 0, we have 2y. So 2y also will tend to 0 only. Right? So we can apply the result in the numerator. So this will become 1. As y tends to 0, 2y also will tend to 0. Therefore we can apply the result limit x tends to 0, sin x by x is 1. So this will become 1. 1 into 2y divided by limit y tends to 0, y into cos 2y. Now y will get cancelled. So we got 2 into 1 by cos 2y. Limit y tends to 0, cos 0 is 1. So the answer will be 2. 2 into 1, which is 2. Right? So it all depends on the question. What are you going to get? Appropriately, you have to go with the method like substitution or using the result. Whatever you are going to perform, you have to do it. Right? Let us see another method of problem which we have solved under limits. This is another kind of problem where the question is given and they have defined the function like piecewise they have defined. If x is less than or equal to 0, this is the definition. If x is greater than 0, this is the definition. They asked you to find limit x tends to 0 f of x and limit x tends to 1 f of x if they exist. So when the limit will exist, when both right hand limit and left hand limit exist and both should coincide, then only the limit of the function will exist, right? So we have to find both left hand limit, right hand limit, and we have to check whether both are equal. Then only the limit of the function will exist and it will be equal to that coincide value, right? So first let us find the left hand limit. Limit x tends to 0 minus f of x, which is nothing but left hand limit means from the left hand side it approaches 0, which means less than 0. So less than 0, the function is defined as 2x plus 3. So 2x plus 3, if we apply the limit, we got 3. Right hand limit means from the right hand side it approaches 0, which means greater than 0. Greater than 0, the function is defined as 3 into x plus 1. So we got 3. So both right hand and left hand limit exist. Both are equal to 3 and hence the limit of the function will exist at 0 and which is nothing but 3. Right? Hope you got it. Now let us see the next subdivision. There they have given you limit x tends to 1 f of x. They asked you to find out limit x tends to 1 f of x. Same way we have to analyze left hand limit and right hand limit. Left hand limit, if you take approaching the value 1 from the left hand side, approaching the value 1 from the left hand side, anyhow it is going to be greater than 0. Right? Approaching 1 from the left hand side is also going to be greater than 0. Approaching the value 1 from the left hand side is also going to be greater than 0. So the definition of the function here for both is going to be 3 into x plus 1. Okay, because approaching value 1, we are going to take the values closer to 1. We are not going to take the values from here. Right. So the value approaching 1 means closer to 1. Closer to 1 is going to be positive value only, greater than 0. We are not going to check from minus 10 and minus 11. No. We are going to check the values which is very close to 1 from the left hand side and very close to 1 from the right hand side. Both are going to be greater than 0. So the same definition and the values are also same. Therefore both the limit exists and hence the limit of the function will exist and it is equal to the same value 6. Right? Hope you recalled all these things. This is another type of problem where the function is defined and they have given limit x tends to 1 f of x is f of 1. They asked you to find the values of a and b. We can find some unknown values in the definition of the function. So how to solve this problem? The same way, the limit of the function will exist only when the left hand limit, right hand limit exist and both should coincide. So limit x tends to 1 minus f of x, let us find out. Approaching the value 1 from the left hand side is going to be less than 1, right? So the definition is a plus bx. So if we put x as 1, we got a plus b. The same way, right hand limit is greater than 1. Greater than 1 is b minus ax. So we got b minus a. And for the limit to exist, it should be, both should be equal, and they have given you limit x tends to 1 f of x is equal to f of 1. What is f of 1? F of 1 is 4. So all the things should be equal to 4. Right? Then only the limit of the function will exist. So a plus b is also equal to 4. B minus a is also equal to 4. So we got two equations and two unknowns. So if you simplify by elimination method or substitution method, we can find what is a and b. Yes? Hope you understood, guys. Then we have learnt about derivatives. What is meant by a derivative of a function f? It is denoted by f dash of x. F dash of x is limit h tends to 0 f of x plus h minus f of x divided by h. This is called first principle of derivative. The derivatives can be denoted in many ways, like f dash of x, d by dx of f of x, then dy by dx if y is equal to f of x, capital D of f of x. All these things are different denotions for a derivative. Derivative of the function with respect to x. So what is the first principle of derivative? If f dash of x is equal to limit h tends to 0. Using limiting process only we have defined the definition of the derivative. So derivative of the function f of x is limit h tends to 0 f of x plus h minus f of x divided by h. Right? Now let us see few examples under derivatives. Find the derivative of the function f of x which is equal to 2x square plus 3x minus 5 at x equal to minus 1. Also they asked you to prove this. So what is f dash of x formula? F dash of x is limit h tends to 0 f of x plus h minus f of x divided by h. At x equal to a means in the place of x we have to put a. Right? Now our question is to find at x equal to minus 1. So f dash of minus 1 is limit h tends to 0 f of minus 1 plus h minus f of minus 1 divided by h. Hope you understood. In the place of a we have written minus 1 because at x equal to minus 1 only we have to find out. Right? So after this step what we have to do? What is f of x definition given in the question? F of x is 2x square plus 3x minus 5. So in the place of x we have minus 1 plus h. So 2 into minus 1 plus h the whole square plus 3 into minus 1 plus h minus 5 is our f of x minus f of minus 1. Again in the place of x we have to put minus 1. So 2 into minus 1 the whole square plus 3 into minus 1 minus 5 divided by h. We have to expand this using a plus b the whole square identity. Simplify all those things. At last we got 2h square minus h by h. Again we have taken h as common. We got 2h minus 1. So limit h tends to 0, 2h minus 1. So if we put h is equal to 0, we got minus 1. So f dash of minus 1 is minus 1. This is how only we have to find the derivative of the given function. Right? I hope you people are recalling what we have learnt. Yes, let us see another example. Find the derivative of sin x at x equal to 0. So f of x is sin x. Right? Now we have to find out f dash of 0. F dash of x we have to find. Derivative means f dash at x equal to 0. So in the place of x we have to put 0. So f dash of 0 we have to find out. So what is the formula? Limit x tends to 0, f of x plus h. So 0 plus h minus f of x, f of 0 divided by h. So in the formula we have to put the x value. Alright. So what is f of x? F of x is sin x. So in the place of x we have to put 0 plus h. So sin 0 plus h is sin h minus sin 0 divided by h. Sin 0 is 0. So sin h divided by h. Limit h tends to 0, sin h by h is 1. Because we know the result, no? Limit x tends to 0, sin x by x is 1. So that result we have used here. Right? Like this you have to solve these kind of simple problems. Then we have learnt about algebra of derivative of function. As we have seen algebra of limit of the functions, we have derivative of the functions as well. D by dx of f of x plus g of x is nothing but d by dx of f of x plus d by dx of g of x. We can split for subtraction, addition, and for multiplication we have a rule called product rule. What is that product rule? uv the whole dash is u dash v plus uv dash. It is not like simply separating f dash of x into g dash of x. Okay, for a derivative of the product we have product rule. For addition and subtraction you can just split, but for multiplication it is first you have to differentiate f and then you have to keep g as constant, plus g as g you have to find the derivative, and f you have to keep it as constant, which in short we will call it as product rule or Leibniz rule, and which is uv the whole dash is u dash v plus uv dash. And similarly we have a quotient rule, which is u by v the whole dash is denominator we will be having v square u dash v minus uv dash, u dash v minus uv dash. Okay. Then is d by dx of x power n is n into x power n minus 1. This you can expand it for the polynomial as well. D by dx of x power n is n into x power n minus 1. So if f of x is equal to a n x power n, this will become a n into x power n differentiation is n into x power n minus 1. n minus 1 now, n minus 1 into x power n minus 1 likewise. And if you call the last term is constant, if you differentiate it will become 0. Okay, x if you differentiate you will get 1. d by dx of x is 1, d by dx of constant is 0. So you have to remember all these things. So what are all the things we have learnt now? Product rule, uv the whole dash is u dash v plus uv dash. Quotient rule, u by v the whole dash is u dash v minus uv dash divided by v square. d by dx of x power n is n into x power n minus 1, and you can extend it for the polynomial. See, here are a few examples. Compute the derivative of this. Here we can use x power n formula. d by dx of x power n is n into x power n minus 1. So this will become 6, and 6 is constant. So you have to keep that 6 as such. High x power n. So n into x power n minus 1. 100 into x power 100 minus 1 is 99. Here 55 into x power 54. And x if you differentiate it will be 1. Okay, simplify and give the answer. The same way if we apply the result here, and then you have to find at 1. So after finding f dash of x, in the place of x we have to put 1. So these are all very easy problems. If you see this example here, we have to use the quotient rule, u by v, right? Here we have taken u as x plus 1, v as x. So u dash x plus 1, if we differentiate we will get 1, v dash is going to be 1. So first assign. Whenever you are going to apply the quotient rule or product rule, first select which is going to be your u, which is going to be your v, find u dash, v dash separately, and then substitute in the formula so that you will get the thing easily. Okay, then substitute here u dash v, u dash value is 1, v value is x, minus u v dash, u value is x plus 1, v value is v dash value is 1 divided by v square. So substitute, you will get the answer. Then we found the derivative of sin x using first principle. So if they ask you to find the derivative of sin x using first principle, you have to do like this only. What is the first principle? Limit h tends to 0 f of x plus h minus f of x divided by x. So in that we have to proceed the problem. In the place of x we have to put x plus h. Now you have to apply s minus s formula. Then after applying s minus s formula, which is 2cs, right? Then we got 2x plus h divided by 2 into sine h by 2. Yes, so if we simplify, we will get cos x plus h by 2. And we need h by 2, so bring this 2 to the denominator. Now here we can apply sin x by x rule, because as h tends to 0, h by 2 will also tend to 0. Again we got, so this will become 1. So limit h tends to 0, cos x plus h by 2 will become cos x. Right? So d by dx of sin x is cos x. This is a formula you have to remember. This we found using first principle. Using first principle we found the derivative, so you have to by heart it, and we will be using in the problems. Alright, so d by dx of sin x is cos x. So if they mention using first principle find the derivative, you have to undergo with this. Or else if they give question like this, like find the derivative, you can directly apply the known results like this and you can find the answer, right? So these are all the results we have learnt in derivatives of trigonometric functions using first principle. We found all these things, so you have to by heart. If you come across cos x in any problem, directly while differentiating cos x, it will be minus sin x. You can directly write. There you don't want to undergo first principle, right? So what is d by dx of x power n into x power n minus 1, d by dx of x is 1, d by dx of any constant is 0, differentiation of sin x is cos x, differentiation of tan x is secant square x, differentiation of cos x is minus sin x, differentiation of cot x is minus cosec square x, differentiation of secant x is secant x tan x, and differentiation of cosec x is minus cosec x cot x. You have to remember all these formula. You have to learn. Okay. If you remember all those derivatives and product rule along with quotient rule, you can do wonders in the derivatives chapter. See, if you have a question like sin x into cos x, immediately product rule should strike your mind. What is product rule? uv the whole dash is uv dash plus u dash v. So here u I am going to choose it as sin x, v as cos x. So u dash sin x differentiation is cos x differentiation is minus sin x. For this only I told you should by heart all those derivatives. So once you have done this, you can substitute in uv rule and get your answer. That's it. Okay. See, f of x is secant x. Secant x can be written as 1 by cos x. Now you can go with u by v rule. Likewise, you can do the problems. If you have question like this, 5 into, directly you can do sin x. Here you don't want to do product rule. When you have two functions, product of two functions, you have to go for product rule. When you have a constant and a function, that constant is like a scalar. We have seen no scalar can be removed and we can apply the derivative algebra. So you can do that. So 5 into sin x differentiation is cos x, minus 6 into cos x differentiation is minus sin x, plus constant differentiation is 0. Directly you can put and solve it. Right? Here in this problem we have cot x, cosec x. So cos x by sin x, 1 by, here u by v rule, here 1 u by v rule. You can undergo and slowly you can do step by step to arrive the answer. That's it all about limits and derivatives. Very easy chapter. Hope you people have recalled what are all the things we have learnt under this chapter. So I want you to do these questions as practice, and if you have doubts you can ask me. Thank you, students.